5 Agritech Trends Quietly Reshaping Farming in Nigeria, 2026 data. Nigeria spends over $10 billion annually on food imports, according to recent trade estimates, despite having more than 70 million hectares of agricultural land. That gap is not just about land. It is about productivity. In 2026, technology adoption in agriculture is no longer optional. It is the dividing line between stagnation and competitiveness. In this video, you will not hear speculation. You will see 5 measurable agri-tech trends already operating in Nigeria and across Africa, what they are doing economically, and where the limitations still exist. Nigeria's average crop yields remain significantly below global averages. For example, maize yields are often less than half of global benchmarks. Climate volatility is increasing, flooding in some states, drought in others. At the same time, population growth continues to raise food demand. Across sub-Saharan Africa, the African Development Bank estimates that closing the yield gap could unlock billions in annual agricultural output. Technology is not a silver bullet, but it is one of the few scalable tools capable of improving efficiency without expanding farmland. The 5 trends. Trend 1. AI-powered weather and yield prediction. Artificial intelligence in agriculture primarily means using machine learning models to analyze weather data, soil data, and historical yields to forecast outcomes. In Nigeria, platforms like Zenvus and other agri-data startups are using analytics tools to provide predictive insights to farmers and agribusinesses. Across Africa, precision weather forecasting tools have shown measurable improvements in planting decisions, reducing losses during irregular rainfall seasons. The economic impact is risk reduction. When farmers plant at the correct time and adjust fertilizer use based on data, input costs fall and yield stability improves. The limitation is data infrastructure. Reliable localized data remains uneven, and many smallholders lack direct digital access. Technology does not eliminate uncertainty, it narrows it. Trend 2. Satellite crop monitoring. Satellite crop monitoring uses high-resolution imagery to track crop health, moisture stress, and disease patterns from space. Companies such as Crop to Cash in Nigeria and international satellite data providers are integrating remote sensing into farm management systems. Satellite data can detect vegetation stress before it is visible to the human eye. In large-scale farming operations, this can prevent substantial yield loss. The economic effect is early intervention. Instead of treating an entire field, farmers can target specific stressed areas, reducing chemical and water waste. The challenge is cost and interpretation. Data alone is not value. Farmers need advisory systems to translate images into action. Observation is powerful. Interpretation determines impact.
Trend 3. IoT soil and irrigation sensors. Internet of Things sensors are small connected devices placed in soil to measure moisture, nutrient levels, and temperature in real time. Zenvus and similar African agritech firms have piloted sensor-based monitoring systems in commercial farms. Research consistently shows that precision irrigation can reduce water use by up to 30% while maintaining or improving yield under certain conditions. The economic implication is efficiency. Water, fertilizer, and energy are major cost drivers. The limitation is upfront investment and maintenance. Sensors require power, connectivity, and technical support. Efficiency is scalable. Hardware access is the bottleneck. Trend 4. Climate-smart greenhouse systems. Climate-smart greenhouses control temperature, humidity, and irrigation, allowing year-round production. In Nigeria, companies like Soilless Farm Lab have demonstrated hydroponic greenhouse systems capable of producing vegetables in urban environments. Greenhouse tomato yields per square meter can significantly exceed open field production, especially during off-season periods. The economic value lies in consistency and premium pricing, particularly in urban markets like Lagos and Abuja. The constraint is capital intensity. Greenhouses require financing structures that many smallholders cannot access. Controlled environments reduce climate risk. They do not eliminate financial risk. Trend 5. Carbon credit integration for smallholders.
Carbon credits allow farmers to earn income by adopting practices that reduce emissions or store carbon, such as regenerative agriculture. Across Africa, pilot programs supported by international climate finance institutions are integrating smallholder farmers into voluntary carbon markets. If structured properly, farmers can receive payments for soil carbon sequestration and sustainable land practices. The economic opportunity is diversification of income beyond crop sales. The challenge is verification and fairness. Measuring carbon accurately requires technical monitoring, and payment distribution systems must remain transparent. Climate finance can support agriculture. It must be built on credible measurement. Technology adoption in Nigeria still faces structural barriers. Electricity supply remains inconsistent in many rural areas. Internet penetration is improving, but not universal. Agricultural financing remains limited, particularly for small-scale farmers. Some of these technologies, like greenhouse systems and precision irrigation, have proven impact in controlled environments. Others, such as carbon integration for smallholders, are still in early-stage scaling phases. Evidence must guide optimism. Infrastructure determines speed. Conclusion. In 2026, AI forecasting, satellite monitoring, and soil sensors are already influencing commercial agriculture in Nigeria. Climate-smart greenhouses are economically viable in high-demand urban corridors. Carbon credit integration is emerging, with careful experimentation underway. Agricultural transformation will not come from slogans. It will come from measured adoption, infrastructure investment, and credible data. Technology is not replacing farmers. It is redefining the margins on which they operate.